Hello and welcome to yet another riveting video over geometry, and this is a video over section 4, which is special parallelograms. We've talked about what a parallelogram is, and we're talking about some special cases of things that are parallelograms, and you'll be very familiar with pretty much rectangles, squares, and then rhombi. Oh my! Okay, so our objectives today, we want to complete the steps to prove theorems about properties of parallelograms. We want to solve real-world problems involving rhombi, rectangles, and squares, okay? So, we have this graphic here, and we have a parallelogram, and we have three special cases of types of parallelograms. And this one is a rhombus. Okay, this one's a rhombus. Okay, and we know that all four sides are congruent, okay? We have a square, all right, where we have all four sides are congruent and all the angles are 90-degree angles. These are not 90-degree angles, okay? And then we have a rectangle, okay? And rectangle, we know that the opposite sides are congruent and you have 90-degree angles. So they're all kind of different special types, and we'll be able to distinguish between all three of them. So, what we know first about rectangle theorems is that a parallelogram is a rectangle if one of its angles is a right angle, okay? And we can then conclude that if one of the angles is a right angle, all of the angles are right angles, okay? And then the main thing about rectangles is the rectangle diagonal theorem, okay? And that means that a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so we would know that AC, that this length here, would be congruent to segment BD, okay? This one here, all right? So if the rectangles are congruent and you know you have a parallelogram, then you have a rectangle, okay? So let's take a look over here. Properties of a rhombus. A rhombus, is a parallelogram. All four sides are congruent. The diagonals are angle bisectors, okay? So the diagonals bisect these angles here, all right? So you would have these, all four of these angles would be congruent, and then these angles would be bisected as well, okay? The other thing is that the diagonals are perpendicular, okay? And so if we can show that the diagonals are perpendicular, then we have a rhombus, okay? And we also know that all four sides are congruent, all right? And so I would come in here and be able to label that, okay? So those are the properties we have of rhombi. Okay, a square is a combination of both a rectangle and a rhombus, okay? We know that a square is a parallelogram. All four angles are right angles, okay? They have congruent diagonals. So let me draw in some diagonals here as well. Okay, so we would know that AC is congruent to BD, okay, as well. And the diagonals are also angle bisectors, okay, and they actually create 45-degree angles. I'm going to come in here and bisect all those angles, okay? And then we also know that they have perpendicular diagonals. So we can also come in here and say that these lines are perpendicular. So, not a whole lot of actual notes, just a lot of information on these. So when you look here, and the only other thing I want to come in here and do is say that the opposite sides are congruent still. So they still have the same properties of parallelograms, where all those same properties, but there are some special cases with these. And usually we can tell these things by their diagonals, okay? And we'll kind of go through that in a later section. All right, so let's apply some of these properties of special parallelograms, and let's do this first problem where it says Sanjay has 250 feet of fencing to use to enclose a rectangular grassy area for his dog to play. Isn't that nice? Okay, he wants to use 80 feet of his house as the width of one side of the play area. What is the maximum length the rectangle can have. All right, so what we have here is this. Let's just draw a picture, okay? And so let's draw a generic rectangle, okay? And let's kind of label that as these sides are congruent and these sides are congruent. And it says that, you know, the perimeter, he has 250 feet of fencing to use, okay? So we know that the perimeter is equal to 250 feet, okay? And we want to use 80 feet of this house as the width, all right? So I'm going to come over here, label this the width and the length. It doesn't matter which one you choose to label those, but the width is going to be x, the width is going to be 80 feet, okay, and then the length is going to be x, all right? And what we know is that, you know, this length is also going to be x, and this is also going to be 80, okay, 80 feet. And so what I want to do is think about the formula that I have for perimeter, and that's just adding up all the sides, okay? And that would be x plus 80 plus 80. All right, and when I add two things like this, I can really rewrite that as 2x plus 2 times 80, okay? Or you could just add 80 and 80 to get 160. All right, so now I know that my perimeter is 250 feet. And I'm going to substitute that in for p down here into this other equation. And that's going to give me 250 feet is equal to 2x plus 160. Okay, and if I take that and I subtract 160 from both sides, we'll subtract 160 from here and here, and that's going to end up giving us 90. Okay, 250 minus 160 is 90 is equal to 2x. Okay, I'm going to take that, bring that up here, and so we've got 90 is equal to 2x. I'm going to divide both sides by 2 and 2, and we get that x is equal to 45. And we're going to call that feet. Okay, and so that would be the maximum length that the rectangle could have. Okay, all right, let's take a look at another one, and it says that a new walking path around a playground is in the shape of a square. So we have a square here, all right, and it says what is the approximate distance from one corner of the path to the corner opposite, round to the nearest meter. So what I want to show you guys is that, first of all, we have a square. So all these sides are congruent, all right? And if these two sides are 80, then that means that these other sides would also have to be 80 meters, okay? And they want to know the distance from one corner of the path to the corner opposite. So we're being asked to find the length of that path, okay, to the nearest meter. All right, so what I have, the other thing that we know is that we have a right angle here, okay? We also have a right angle here, and these are right angles, and so forth. Now, we also know that this diagonal bisects these angles. So we know that if we take 90 and cut it in half, that we get 45 degrees. So this is a 40-degree angle. This is a 45-degree angle. Okay, and we're trying to find this length, and we'll call it D for diagonal, all right? Now, when I look at this, and I'm just going to highlight this, what you notice, or what you should notice, is that this is a 45-45-90 triangle, okay? And it has the properties that this is length L, this is length L, and this is L times the square root of 2. Okay, and so with that, what we can do is I can set this up and say that my length L is equal to 80 meters, okay? And then I know that my distance D is equal to that length L times the square root of 2, okay? And I get that from here, and I get that from here, all right? I just set up those equations. Okay, if I know that L is 80 meters, then I can take that value of 80 and plug it in for L. Okay, so I get that D, my diagonal, is equal to 80 meters times the square root of 2. Now let's plug that into the calculator and get a number for that. And that's going to give us that my distance, and we're going to round to the, the nearest meter. So I've got that my distance is 100 113 meters, okay, and that's approximately because we're rounding to the nearest meter. All right, usually I think we got like that D was equal to 113.137, and if we're rounding to the nearest meter, okay, then the 1 tells us that we need to stay at 113, okay? Okay, and that's it. That's all I have for this particular section. I think it won't be too bad as long as we, think about the properties that we already know about parallelograms and then, relating that to some special types of parallelograms. All right, thanks. See you in a bit. Bye.